Okay, now look, we discussed here, huh?
Until
And random emission.
yes, a random emission.
Now detection of radioactive emissions. So we are going to discuss uh,
Yes, sir. I read this
how
part.
how how we will detect radioactive emissions. Radioactive emissions means alpha, beta, gamma, and they don't have any color, no smell, no sound. So uh, your nose, your eyes, your ear, they cannot detect it. Okay,
None of the sensors.
yeah, none of the sensing devices or organs can detect it. So we need special type of detectors to detect them because though we cannot understand around us there is any radioactive emission or not, but they are affecting our body. If we are close to alpha, beta, and gamma, then there are some effects in our body. Okay, and because of this, there will be generation after generation there will be some problems like damaging cells, cancer, and ionization in the body. All these things will happen. Okay, and it will cause even severe damage of our body organs, which can lead to death. Okay, now we are
Yes,
going
sir.
to find some detectors to which we can use to detect the radioactive emissions, their strength, their counting numbers, so that we can be aware and be away from these radioactive emissions. We can be more careful. We can take measures to avoid them, to reduce the radioactivity. So please go through from here. Huh? Radioactivity. Hmm. Hello, Karim. Loudly.
Yes, sir. I'm listening.
Yeah, loudly you read. From radioactivity is invisible.
Yes, sir. Radioactivity is invisible, has no smell, make no sound. In fact, it cannot be detected by any of our senses. However, because radioactivity we can measure it using a variety of methods using following detectors. Sir, what is this called?
Geiger
GM tube,
Mueller. Yeah, Geiger Mueller.
Geiger-Müller tube,
Hmm. Hmm.
photographic film, gold leaf, electroscope, spark counter, cloud chamber, bubble chamber, and modern detector.
Yeah, the first one is Geiger Mueller tube or GM tube. Huh? So this one, you see, we have a tube here. This one, see, GM tube. And if we are keeping one source in front of it, alpha, beta, and gamma source is going inside it. And there is one, you know, here you see, there is one, uh,
Anode.
yeah, anode. So we have the, you know,
Sir, are you all right? Means, are you fine?
yes, I'm all right. You see, the detectors is detecting the counts, and this one is rate meter or count meter. Huh? Here we are getting the readings. Okay, so how it is working and how the things are, counted. Little bit discussion is going on in the right side. We do not need actually the details how it is working or what is the working principle of GMTU. Only it is a detector. That's it. The GMTU, it is one of the detectors. Okay, just you remember this
Yes, sir.
thing. But the
Okay, sir.
the little bit discussion I gave you for your interest only. Okay. so that you can understand little bit how it is working. So please read it. Huh? Most people.
Yes, sir. Most people have heard of Geiger counter for measuring radioactivity. This is actually this is actually a Geiger-Muller tube, which some forms of counter attached, which is usually tested by that they are best at detecting alpha particle because a particle ionize uh, alpha particle ionize strongly. Different models of GM tube are available for detecting alpha, beta, and gamma radiations, means emissions.
So you are clear about this, right?
Yes, sir.
So here you got one thing, detecting
But
alpha
sir,
particles.
but why do they means they pass through the means glass or something? But why do they just go to anode and react over there?
Can you read this part? For your question, the answer is given here. I know you will ask this question.
Oh. The tube is filled with argon gas and around plus 400 volt is applied to the thin wire in the middle. When a particle enters the tube, it pulls an electron from an argon atom, attracted to the center wire as it rushes towards the wire. Electron will knock the electron from argon atom, causing an avalanche means change of direction.
No, avalanche means plenty in amount, too much.
Oh,
Okay,
so then which what was that means when a
too
radioactive
many
particle is
electrons.
moving and it got deflected?
Yeah, is it clear now
Yes, sir.
how it
Thus,
is
one
working?
single incoming particle will cause many electrons to arrive at the wire. A plus, which can be amplified and counted. This gives us a very sensitive detector. Sir, but why do they move towards the? I didn't still understand.
Okay, very good. I appreciate your question. Look, here we have argon gas, right?
Yes, sir.
Argon gas is normally neutral and its outermost shell electrons are filled, right?
Yes, sir.
So when we are having alpha, beta, and gamma, huh? Especially alpha, they have uh, very strong ionizing capacity. Okay, what they will
Yes, sir.
do, they will pull the electrons from the outermost shell of the argon, and that electron will go to this 4 plus 400 volts, because plus 400 is a very strong volt, right? And electron will be attracted to this plus 400 volts. It is very powerful than even alpha, right?
Yes, sir.
So uh, one of the electrons going there, uh, if it is going there, you are getting one count, right?
Yes, sir.
So when
Means it
there,
counts the electrons.
yes, so if you are getting so many electrons, then you are getting so many counts, right? Isn't it?
Yes, sir.
That means if your amount of alpha particles are entering more, it can uh, pull more electrons, then those electrons count you are getting in the detector. Then beta particles are also coming, right? They are also ionizing. Gamma can also ionize, but it can ionize little bit. That's why this detector, the Geiger-Müller tube, is mainly detecting alpha particles. Huh? Okay, so this one you remember.
Yes, sir.
GM tubes work using the ionizing effect of radioactivity. That this means that alpha the best ionizing capacity. Alpha can be detected better by GM tubes. And they also said that different models of GM tubes are available for detecting alpha, beta, and gamma emissions. So is it clear now?
Yes, sir.
Now, did you take the notes in your copy? Huh?
Like,
Detection of radioactive emission. Then you write Geiger-Müller tube. It is used using the ionizing effect of radioactivity. You write this sentence. Okay?
okay, sir.
This one you write only. This sentence. GM tubes work using the ionizing effect of radioactivity. At least you can recall, yes, what it is. Now, photographic film.
Means a short note for which I describes the whole thing.
Hmm. Notes is there,
Done, sir.
just important thing we are writing, okay?
Yes, sir. Sir, how do you think? What do you think? How many days will it take to finish this?
It depends on you. You come quick, join quick, and finish quick. Okay,
Yes, sir. It would
photographic
be
film.
wasted 7
Please
minutes.
continue fast.
Yes, sir. In 1896, Henry Becquerel, working in Paris, discovered that uranium compound would darken a photographic plate even if the plate were wrapped up so that no light could get it. Radioactivity will darken this fog the photographic film, and we can use this effect to measure how much radiation has struck the film. Workers in the nuclear industry wear film badges which are stuck to the laboratory to be developed. Just like your photograph, this allows us to measure dose that each worker has received, usually each month.
Photographic.
Oh, means they have placed that aluminum and lead so that they can decide, means they can see that gamma
Yes,
particle and means difference.
yes. So here
Sir, does
we have to note down one thing that photographic film,
uranium,
photographic film, uh, who are using
the photographers?
photographic film, this detector, who are using workers in the nuclear industry. Okay,
Okay, sir. Workers
take
in
this
the
note.
nuclear
Take this
industry.
note. Why they are using it?
Because photographic films darkens or fog out
Look. They
when
are
they
using
react
it.
with radioactivity.
Yeah, this allows them to measure the dose they receive monthly. Okay, quickly write it.
So what do you meant by dose?
Dose means how much radioactivity is coming, how much count rate is coming. Okay, what is the intensity of the radioactivity? That is called dose. It is more or less. Is it clear now? Hello, Karim. Karim,
Yes, sir, I was writing.
you write, but you don't mute your mic. Okay, I want to hear from you. Okay, Karim.
Okay, sir.
Okay, look, you are done with this, right? Sometimes doctor is giving you some medicines which you have to take 3 times, two each. Okay,
Yes,
three
sir.
times each of the time you will take two tablets. Okay, and sometimes he is giving only, the doctor is giving only one tablet only once in a day, right?
Yes, sir.
Isn't it? So the one he gave you first, that one is high dose, and the later on he gave you smaller dose, right?
But sir, it is also decided on how much virus or how much infection do I have
Yeah,
inside my
that one
body.
you asked me about dose, I just explained. Now cloud chamber. Continue cloud chamber.
Sir, I didn't finish the writing yet. Just one
Still
minute.
not. Oh,
Sir, I was just improving a bit. Means,
okay. So I have to show you again. Go quickly.
no, sir, I remember what you said.
Yes, do it quickly.
Done, sir.
Then cloud chamber you read.
Yes, sir. There are two types of cloud chamber: the expansion type and the diffusion type. In both type, or alpha or beta particle have leaf trails in the vapor in the chamber, rather like high-altitude aircraft leaving trails in the sky. The chamber contains a supersaturated vapor. So what is supersaturated?
You know saturated.
Concentrated.
Yeah, saturated. So super saturated means it's completely saturated. Okay.
Means no impurities.
Yeah, super saturated means the amount of uh, vapor it can contain. It has completed the you know maximum limit. That is called super saturated. Like
Means
our
when
like
we can't
like our
find any more
yeah,
impurities.
yeah, we cannot give anything more, right, from outside. That is called super saturated. Is it clear?
Yes, sir.
Okay, now continue please.
Example, methylated spirits, which condenses into droplets when disturbed and ionized by the passage of a particle. You can clearly see the direction and energy of the particle. Low energy particles only leave short trails. Occasionally, a particle collides with an air molecule and changes direction. A cloud chamber shows the randomness of radioactivity emission clearly. Expansion cloud chambers chambers use a vacuum pump to briefly produce a right condition for a trail to form, while the diffusion type showed in the video link below use solid carbon dioxide to cool the bottom of the chamber and produce a temperature gradient which trail can be seen continuously.
Okay, good. Now you see diffusion cloud chamber and expansion type cloud chamber. We have
So will I see the video later on?
Yeah, yeah, later on, not now, because you have to go fast, right? I gave you this
Yes, sir.
one, so you manage some time to see the video. Now, what I have to note down, you see, this one, you see, I gave in italic form.
Which
Some
one,
of the
sir?
things I gave in
Yes,
italic
sir, I
form.
understand.
So alpha particles are best for this. That means the cloud chamber also best to detect the alpha particles because it's also ionizing
Because they
using
are
the
straight and
ionizing.
gives a short ray.
Yeah, it's also using the ionizing property. Okay, and
Oh,
alpha
that is the
particles.
reason.
Yes, that's why alpha particles are best for this. Now, another thing you have to note down that low energy particles only leave short tails. So you have here short tails, long tails, right? So short tails one have low energy and long tails they are showing you more
High
energy,
energy.
right? And there is very important one thing you see by using uh, cloud chamber we can understand that radioactive emission is random, right? It's going in different directions. Look here.
Yeah, because that might have
So here
collide with
you see
any of the atom.
we understand it from the cloud chamber that a cloud chamber shows the randomness of radioactive emissions clearly. So you write this all three, huh? The italic these three. Please do it quickly.
Sir, so what shall I write?
You should write this one, the italic one. Alpha particles are best for
Best for
detecting.
cloud chamber
Yeah,
experiment.
yeah. The next one is low energy particles leave short tails. Then the third one you see cloud chamber shows the randomness of radioactive emissions clearly. Is it done?
No, sir, the third one is left.
Yeah, quickly, do quickly.
No, sir.
Yeah, then next modern detectors. Quick.
Yes, sir. Modern instruments are much more sensitive than the other listed above. Scintillation.
Yeah, scintillation detectors.
Scintillation detectors work by striking pseudo particles such as sodium iodide and producing a tiny flash of light. This is amplified by a photo multiplier tube. What is that, sir?
This is a device which amplify the flash of light you are getting, right? Hello.
Amplify means
Amplify means like you don't know that amplifier we are using for sound. You know, increasing the
Oh, it's
sound.
something like when it sees
Yeah, yeah.
something, it just
Like
makes a
you are
sound.
giving in microphone the sound, it's amplified, and we are getting bigger sound,
Oh, understand,
louder
sir.
sound in the sound box, right? That is called amplifier.
Okay, sir. Which result is a burst of electron large enough to be detected.
Yeah, scintillation,
Scintillation detect. Yes, sir.
scintillation.
Sorry, sir. Scintillation detectors from the bases of the handheld instrument used to monitor contamination in nuclear power station. They can recognize the difference between alpha, beta, and gamma radiations and make different noise such as beep or click accordingly.
Okay, wait here. Then you write about scintillation detectors, and you write only the italic form. So scintillation detectors, it is a handheld instrument. This is the first thing, and it is used in nuclear power stations to check the contamination in nuclear power stations. Then it can recognize alpha, beta, and gamma radiation separately. Huh? And for alpha, it is giving one kind of noise. For beta, it's giving different, sound. For gamma, it's giving another sound.
So can I write it in points like handheld instrument
Yes.
can
Quick.
differentiate between alpha, beta, and gamma?
Yes. That will be better. A handheld instrument, and it is used in nuclear power station to detect contamination.
Sir, what type of contamination?
Contamination means there is how much alpha, beta, and gamma radiations are coming. That is called contamination.
Uh, does that mean one type of element can give all
Yeah,
sorts
in
of
power
means
station,
alpha, beta, and gamma,
listen,
all of these radiations?
In our power station, we have shielding to reduce the you know this alpha, beta, and gamma radiations exposure. Okay, so if that shielding is working properly or not, okay, if it is not working properly, we can say it is contaminated. The weather is contaminated or the surrounding is contaminated. Is it clear?
Sir, can you explain once again?
We are saying that in nuclear power station we have shielding around the power station to reduce the alpha, beta, and gamma radiations. Okay, so that they are
Means
not
spread
coming
of
up.
alpha, beta, and
Okay, alpha, beta, and gamma radiations are coming from the radioactive sources, right?
yes, sir.
So when they are coming out, if we are giving
Means
shielding,
that shielding helps us to
yeah,
stop
yeah,
spreading
stop
of
them.
those
Yeah,
emissions.
yes, they are stopping the emissions. So they can reduce the emission to come out, to expose in our body or in the environment, in the plants, in the creatures. Okay, so is it clear now?
Yes, sir.
So continue, please, quick. Are you done?
Yes, sir.
Then continue. The last one, solid state detectors. Karim, loudly.
Yes, sir. At the most up-to-date instrument, they are used in particle accelerator laboratory.
Yes, loudly, please.
Yes, the mom just called me for a second.
Mhm.
To show the result of high energy collision with banks of them clustered around the collision site, feeding data into huge computers. The way they work is way beyond what we need for uh, O levels, but basically they are similar to CCD, charged coupled device, silicon chips used in video camera. So I didn't understand a word.
Okay, so this one is solid state detectors, which one is using actually for larger scale, okay? And it is used for solid state detectors. It is used in power stations. It is used for, big projects, okay, in where the nuclear reactions are going on. So this one is using also computer, okay. We are getting here computer for detecting the data or feeding the data. Is it clear? Hello,
Yes, sir.
solid state detectors, they are using the computer, huge computers for feeding data. And how they are doing it, we don't have need to discuss them detailed in O levels, IGCSE O levels. But a little bit idea you are getting that they are using charged coupled device, that is silicon chips, used in video cameras. Okay, so here you do not need to write anything. You just write the name of detectors, solid state detectors. That's it. Is it clear? Hello.
Yes, sir.
So what your mom told? Hello.
She just asked for something
What she asked
about the pen. Where
about
is it in my
about
shelf?
your studies or
No, sir, pen.
physics?
Means no, sir, she needed a pen, so she just asked where it is in the shelf
Okay,
because
now
mine one is too.
now you continue characteristics of three types of emission. Okay,
Okay, sir.
characteristics means their properties. Okay, their behavior, alpha, beta, gamma. Continue. You give the heading in your copy, characteristics of alpha, beta, gamma. Huh? Then what I am saying, you write that one. Alpha, beta, gamma, you read, then I will tell you what you have to write, then you write. Okay, continue.
Okay, sir.
Alpha.
Characteristics of types of emission. Alpha particle consists of two protons and two neutrons.
Hmm.
It is equivalent to a helium nucleus.
Hmm.
It has a mass of 4U, atomic mass unit into 4 into the mass of proton, and a charge of +2. Example, alpha particle travel up to
Not example,
about one
plus
tenth
2e, plus 2e. That means
oh
charge
two
of
electron.
2 electrons here. Plus.
Alpha particle travel up to about one tenth of the light speed. So what should I write?
Yeah, you do not need to write anything now. I will tell you. Just go on.
Okay, so beta particles are electrons emitting with varying speed, which can be as high as ninth of the speed of light. Like electron, they carry negative charge of minus one electron. Beta particles are much lighter than alpha particles. Gamma rays are electromagnetic waves of very short wavelength. They are often emitted at the same time as alpha or beta particles. Gamma rays are massless.
Okay, continue. Ionization.
Ionization. Ion is a charged atom formed by losing or gaining electrons. All three kinds of emission are capable of creating ions. A particle knock electron out of nearby atom, thus ionizing the atom. The alpha particles are much heavier than the electron and can simply dislose them from the atoms. Okay, choose me. Thus, they have the most powerful, sir, a alpha ionization একটু বুঝাবেন স্যার?
Yeah, alpha particles, they have the charge of two, right? Two,
Yes, sir.
two positive charges. So if you consider their ionizing capacity is more than beta and gamma, right? Because beta
Yes, sir.
has only one electron, so its ionizing capacity is half of alpha. And gamma, they don't have any charge. However, because of their speed, they can ionize, right? And because of their speed, that means speed means if something has energy, kinetic energy that can uh, do, some work on anything, right? So they have also ionizing effect, but it is least, not like alpha and beta. So they are saying alpha particles are heavier than the electrons. That means in outermost shell of the atom, you have electrons, right? And
Yes,
electrons
sir.
are very lighter element, lighter particles, and alpha particles, they are very heavy in comparison to electron. Alpha particles are very heavy. Now, you think of a cycle is one person is going through cycle, huh? And a big truck is coming, huh? Cycle is, for
Yes, sir.
example, going with high speed, or cycle is staying in one place, but the truck is coming, it's very heavy. So if the truck is touching the cycle, what will happen?
It's simple. The truck will move over and
Yeah,
rotate and it will burst.
yeah. So we are giving this example. If it's not, move over the cycle, just is touching the cycle, what will happen? The cycle will
The
go
truck
far
will
away,
burst.
right? Cycle
Yes, sir.
cycle will go far away with that touching. So this way, the electrons, they are very light thing, right? And if you are the alpha particles are touching or going very close to the electrons, then the electrons can be easily dislodged from the atoms, right?
Yes,
Hello.
sir.
That's why the alpha particles, they have greater ionizing power. So I think you are clear now. Hello, are you clear?
Yes, sir. I'm listening. Yes, sir.
Is it clear?
Yes, sir. Fairly.
Yeah, fairly, not strongly.
Not yet, sir.
Okay, now again I'm saying, like, the track is in its place, right?
Okay,
Uh,
sir.
one,
Means alpha particle is the truck.
yeah, alpha particle is the track. Now, uh, if any other vehicle with a small mass, like a cycle, is going and touching the track, what will happen?
It will
Track will
fall
not
over.
move. truck will
Yeah,
not move,
because it
right?
has a higher mass and gravity is working
Yeah,
on it.
but if the truck is moving and touching the cycle, what is happening? Cycle is going
Still,
far
the
away.
cycle will fall.
Yeah, cycle will fall or cycle will go away, far away, right? So you understand that what they are
Means
saying.
if beta particle acts with means collide with alpha particle, the effect will only be on beta particle.
Yes, yes. So electrons, when they are having alpha particles closer to them, they can easily dislodge from their shells, right? Dislodge means they are coming out from the shells. Is it clear? If electron is coming out from the shells, that means it is ionized, right? The atom is ionized.
Yes, sir.
Now it is clear to you strongly?
Yes, sir.
Okay, not fairly, strongly. Okay. Now
Yes, sir.
continue,
Yes, sir.
continue beta particles.
Beta particles are less strongly ionizing than alpha particle, but more than gamma rays. It is less likely for a lighter bulb to dislodge an electron.
So is it clear about the beta particles are not that heavier or not that charged. Beta particles have only one charge. So it's have the ionizing capacity, but it is less than alpha particles. Is it clear now?
Yes, sir.
Okay, then continue. Gamma rays. Karim, faster.
Gamma rays are.
Hmm.
Sorry, I thought you would suggest read ahead, so I was waiting.
Go forward.
Gamma rays are least ionizing. Yes, sir. Gamma rays are the least ionizing. Yes, sir. Gamma rays are the least ionizing of the nuclear radiation as it is uncharged,
Yes.
penetrating power.
Hmm. Continue.
Alpha particles are the least penetrating of the nuclear radiation and can be stopped by a sheet of paper. They can only pass through a few centimeters of air. Sir, aren't
Hmm.
they strongly energized means alpha particles are strongly ionizable but not doesn't consist of much energy.
Because they don't have the speed like gamma rays. Gamma rays have the
Means they
speed.
don't have enough energy.
Yes, if they don't have speed, that means they don't have any that much kinetic energy. Is it clear?
Yes, sir.
Speed is related to kinetic energy. Continue.
The motion of an object. Yes, sir. Beta particles are more penetrating and are stopped by 1 millimeter sheet of aluminium. Sir, isn't it 2 centimeters? Oh, sorry. Yeah, yeah, it's right.
Yeah,
The
continue.
fastest beta particle have a range of a meter so in air. Okay. Gamma rays are most penetrating nuclear radiation. Intensity of gamma radiation can be reduced to half by 1 or 2 centimeter thick lead. Sir,
So
means,
you
sir, does this
understand.
mean that even 2 centimeter of lead can't stop a gamma radiation?
Hmm. It can be reduced, but it cannot be stopped completely. Okay. Look here, alpha particles, they can be stopped by sheet of paper, and they
Yes,
can
sir.
also,
Means very thin.
yeah, they can only go through the air few centimeter. That means 5 centimeter. Okay, around 5 centimeter. Now beta particles, they
Means
can
at
be,
max.
yeah, beta particles are can be stopped by aluminum. Okay,
1 millimeter sheet of aluminum.
okay, remember this one. Then gamma rays can be stopped by lead, right? Is it clear?
can be stopped or can be reduced to half.
Can be reduced to half by 2 centimeter lead. If you are giving more, then it can be reduced to negligible amount, right?
Is so much reduced that it is
Yeah.
fairly enough to say stopped.
Yes, yes. Now you note down this table. That's it. On your copy, you note down this table.
Sir,
Hmm.
so what should I write? Characteristics, types of emission.
Yeah, this one you have to write the table on.
Oh, this table.
Yes, yes. Because here we are getting everything together.
I understand, sir. Sir, why did we write 5 millimeter of aluminium?
Because 5 millimeter of aluminum, uh,
But isn't 1 millimeter enough?
look, they are saying range in air 15 centimeter. Okay, but 5 millimeter of aluminum, it can stop, huh? Stop beta. 1 millimeter it can reduce only, cannot stop completely.
I understand. Sir,
Hmm. What?
sir, what do you say?
Yes, tell me.
The screen share, sir.
You need the screen sharing. You don't have the access to Google Classroom.
Yes, sir. Sir, should I take? Sir, you can customize the screen sharing.
Is it clear now?
Yes, sir.
You can see also from your laptop, right? You are using laptop.
No, sir. I use PC.
Use PC. Okay. Same thing. Laptop, PC, same. But that means big screen you are using, big device. Are you done?
Yes, sir.
You are done with the whole table?
Last line is left, sir.
Last line is left, so do it.
But sir, I am using my sources, the
Very good.
Google Classroom to copy it. So you don't need to screen share. You can do.
Yes, thank you.
My pleasure, sir.
I'm actually doing your work. I'm giving you the link for recording of last class so that you
Thank you,
can
sir.
you can have it uh, now. Otherwise, it will be late again. So, are you done there?
Almost, sir. Yes, sir, done.
So, you got the recording of last class, right? In your
Yes, sir.
messenger, I gave you the link. Now, detection of radioactive particles. You already have the idea that alpha particles they have positive charge, beta they have negative, and gamma they have no charge. So they are showing some property in electric field and magnetic field. Look at the diagram here. When we are giving alpha particle inside a electric field, how it's behaving, then beta particles how it's behaving, and gamma how it's behaving. Alpha they are repelled by positive charges because alpha are positively charged. Is it clear? Hello?
Yes, sir.
And secondly, beta they have negative charges, that's why they are repelled by negative charges and attracted by positive. Gamma they don't have any charge, they are going straight. They are not affected by any of the charges, neither positive nor negative. Now in between alpha and beta we have something more. Look, when we are observing alpha particles deflection, the deflection is less, but beta particles their deflection is more. Why? Because the same example I'm giving you, something heavier, alpha particles are heavier, so uh, they something are heavier, they have more mass, they have inertia, right? More inertia. We learned in mass weight density topic what is called inertia, right? The more mass,
Yes, sir.
the more have mass something have, they have
The less.
more inertia. That means they're less likely to move from their place. Okay,
Yes, sir.
that's why alpha is not showing you deflection that much, but beta is lighter. That's why their deflection is more in comparison to alpha. Is it clear?
Sir, alpha is moving towards negative source, isn't it?
Yes, alpha is moving towards negative source and alpha is repelled by
Getting
positive.
deflected. Yes, sir.
Repelled by positive. Both are both the
Sir, so
concepts are
can we
correct.
say that that the deflection is taking at a much faster rate? Because if there was not any means
Just
negative
you
plate.
say that you just say that in alpha deflection is less and beta source the deflection is more. Why? Because beta is lighter and alpha is heavier. That's it. And another point we have to understand from here, beta source, you see, slow energy and fast energy. If something has more speed, then it's getting less time inside the magnetic, yeah, electric field, right? So it will have less curve, right? And something
So
with
what will
less
happen if I mean, while only alpha, if we would have not taken the negative bit, what would have happened?
negative you are not taking.
Yes, sir, because you said it is getting deflected by positive. So will it only be deflected
It's
by
simple.
positive?
It's simple. It's simple that it is repelled by positive and attracted by negative. Both are
Yes, sir.
used here, right?
Sir, but see, my point was that it is also getting attracted by the negative, which is for which we can take as F1, and deflected by positive means
Reflected means repelled.
so just
Repelled
let me
by
explain.
positive. Repelled.
This energy is F1 means attraction. F1 is attraction. This is F2. Yeah, this is F2. So won't these two force create a force 3, which is for which the alpha particles means the way it is moving is much more, or if
Of
the
course,
negative
of
plate
course.
wouldn't.
Of course, it is a very simple thing. Yeah, it is a simple thing. If you are using a stronger electric field, then you will see more deflection. Is it
No, sir, I'm
clear?
not talking about strong electric field.
Yeah, I
I'm
understand
talking
what you
like,
said. I understand what you said. You said about negative attraction and positive repulsion, right? And
yes, sir.
because of that, the force is more stronger. But if you are giving
Yes, sir.
only positive, then the force is not that stronger. It will be repelled, but not that much, right? It will
Yes,
deflect
sir.
it, not that much. That is simple idea. We know it, you know it, everyone will understand it. Just you remember what I'm saying. Don't waste time, huh? Like alpha source, they are having less deflection, and beta they are having more deflection. Why? Because alpha source they have more mass, right? Hello.
Yes, sir.
And beta they have less mass. Is it clear?
Yes, sir.
This one you have to remember, and this one you have to note down. Okay, draw this diagram. uh, you write this heading, deflection of nuclear radiation by electric fields. You write this heading and draw this diagram. Then you, after drawing is done, you note down this, that alpha particles is deflecting less because it is heavier. Beta is deflecting more because it is lighter. Gamma is undeflected because it is chargeless. These 3 points you just note down. That's it.
Sir,
Quickly,
he
quickly.
said that gamma is chargeless. So how can he say that it is undeflected?
If he
Because
does not,
it is chargeless but not uncharged.
chargeless means it does not have any charge.
Oh, chargeless.
Yes. You
I
are
heard that
weightless
a small
means
amount of charge.
no. Chargeless means it does not have any charge. Is it clear?
Yes, sir.
Quickly draw and write the information. See information.
Done, sir.
Okay, you wrote those information?
Yes, sir. I
Okay,
wrote those in points.
yeah, 3 points. Now we are going for another one, that is deflection of alpha, beta, gamma in magnetic field. Okay, are you seeing your notes also, right, from your screen?
Sir, currently I can't see anything.
No, I'm saying you have the notes also, right? You have this notes also, right, in Google Classroom? Hmm?
Yes, sir.
So from there you can also open and check out. Take out this one, the deflection of radioactive particles in a magnetic field.
Sir, there is only black screen.
Yeah.
It is saying that couldn't load.
So is it coming? Your my screen sharing you are seeing?
Yes, sir, it's changing, sir. Flaming hand rule. Yes, sir.
Okay.
Are you in
So
flaming hand rule?
I will explain you.
No, sir. Are you in the page flaming hand rule?
Yes, yes, yes. Fleming's left hand
Okay,
rule.
sir.
So you write the heading. Uh,
Sir, we did it, I think.
we did not do it. You write the heading. Behavior of three types of emission in magnetic field. You write this heading.
Sir, we did it in current, isn't it?
Hmm?
For the magnetic field.
You write this heading. Behavior of three types of emission in a magnetic field. Then I will tell you quickly.
Behavior of.
Behavior of three types is written here. Look, behavior of three types of
Oh,
emission
I
in a
saw, sir. I
magnetic
saw,
field.
I saw, I saw. Done, sir.
Okay, now you write Fleming's left hand rule. Don't write right hand rule, only Fleming's left hand rule. Then you draw this diagram. Draw this diagram and label.
Sir, why only left hand rule?
Because we do not need right hand rule now.
Is it the same thing just on a different hand?
No, no, that is different. I will tell you later. Now
Okay,
understand.
sir.
Fleming's left hand rule. Look here, magnetic field. Magnetic field is in the index finger, right? And current is in the direction of second finger or middle finger, whatever you say. And this one is conventional current flow. Okay, you write their current and you also write in bracket conventional current. Okay, conventional, in bracket you write conventional. Conventional current flow means is going from positive to negative. Okay, Karim, I told you not to mute.
Sorry, I wasn't talking either.
Hmm. Don't mute, huh? Because I need your sound. I need your response. Now look,
Okay,
the
sir.
thumb is showing you thrust. Here they wrote motion of a conductor. You write here thrust in bracket. Huh?
Sure.
Thrust means force. Okay.
Okay, sir.
You write here in bracket thrust. Then give slash. You write force.
Done, sir.
Okay. Very good. Now you
Then
fix
in
your
magnetic field.
yeah magnetic field is for it is first finger or index finger. That's it. I told you it is index finger. Now you fix your left hand the way they showed you. Your thumb, your first finger, your second finger, they should be 90 degree to each other.
Okay, sir.
In between thumb and first finger, there should be 90 degree. In between first finger and second finger, there should be 90 degree. This way you fix your left hand. Then you uh, fix your first finger towards you.
Sir, index finger.
Yes, index finger towards you. And you fix your,
Sir, it is hard.
it is hard, but you do it. And make sure that you are maintaining the angles between thumb, first finger, and second finger. You are maintaining
Sir,
90
can I
degrees.
do it like thumb downwards?
Yes, you can do, no problem. Thumb downwards, you do, no problem. But magnetic field should be towards you. First, fix that
Okay,
one.
sir.
Magnetic field is
Sir, it is
towards you.
hard
Now you
first.
change it. Your magnetic field you don't change. Okay. Now you will change the. Uh, you will make the direction of current right side. Your right side.
Right side. Yes, sir,
Your
I
right
understand.
side.
I already did it.
Yeah.
Current,
You. Yeah. Current will be right side, and
current right side, motion
magnetic
of
field is
conduction
towards you.
downwards.
Yes. Motion of the conductor is downward. That means your force is downwards. Alpha particle will move downwards. Is
Yes,
it
sir.
clear? The dotted
Yes, sir.
the dots are showing you magnetic field out of the page. That means towards you, okay? That's
Sir,
yeah.
whew.
So
Sir,
you
one
understood
minute.
alpha.
Hand is paining.
Yeah. Did you understand alpha source why it's going down?
Yes, sir. Motion of
Now,
conduction.
now you will work with beta source. You will fix the first finger, index finger towards you, but you
Oh,
will
means the
just
motion of conduction is decided because of the charge.
yes, yes. And now what I'm saying, do it, huh? The
Yes, sir.
field is still towards you, or the first finger
Okay,
is
sir.
still towards you, but the current direction will be opposite than
Towards
before,
left and the
towards left. That means beta source is going from left. We know that beta means electron flow, right? And our
yes,
conventional,
sir. It's
yeah,
pinging, sir, again fast.
yeah, I'm saying beta is means flow of electrons, right?
Yes, sir.
And our conventional current flow is opposite of electron flow, right? So your
Yes, sir.
current should be left side. Current should be left side and magnetic field towards you. Then you see the thumb is going upwards, isn't it?
The motion of conduction, because beta source is negatively charged and it will be attracted
Yeah,
towards positively charged
yeah.
force.
So your thumb is going upwards, right?
Yes, sir.
So force is going upwards and beta particles are moving upwards. Is it clear now?
Yes, sir. Can you explain the current again?
Which current?
Sir, beta source current
Okay,
means
I
I
say
understand the
that,
motion of conduction and the magnetic field,
yeah, I am
but
saying
not the
again,
current.
beta source are electrons. You write here, take the notes. Beta source are electrons. So beta source is showing us flow of electrons.
Okay, sir.
The conventional current is opposite of electron flow.
Sir, I understand these things, but one more thing I didn't understand.
You tell me.
So, sir, what are these dots? Means these
I
dots.
told you dotted dot points, they are black points, they are showing you the magnetic field out of the page. Out of the page means towards you. The field direction is towards you. Is
Okay,
it
sir.
clear? So you
Yes, sir.
you draw this diagram, then write this information also that the dot the points are showing magnetic fields out of the page. Right side
Sir,
right side diagram we
sir.
finish drawing.
Yes, sir. Now, sir, I need to ask one more thing. That
Hmm.
uh, I used the left hand rule for alpha. The magnet means for all of those magnetic field was towards me.
Yes,
But
yes,
for
towards you.
alpha and beta, I need to change the hand position. So was
Yes,
it because of the motion of conductor?
no, no. Alpha they have positive charge and beta they have negative charge. That's why. It's
No, sir.
because
Means
I told you already that alpha is positively charged. That's why they
it
are
moved towards
following
the
the,
negative. That is the reason of the motion of conductor.
yeah, yeah.
Yes, sir. So I was
Motion
just
of
asking
conductor,
that.
motion of conductor. I gave you two things over there. One is thrust, another one is force.
Yes,
Okay,
sir.
we are not having
Sir, you
any.
didn't understand my question, sir.
I understood.
Sir,
Now I
my
am saying
question
you.
was that.
Listen, listen.
Okay,
Here we
sir.
don't have any conductor. That's why I gave you thrust and force. Okay. We don't have any conductor here. Mind it. We have here alpha. These are charges. Beta, they are charges. But we are applying the Fleming's left hand rule. That's why we are bringing here magnetic field, current direction. Okay. We don't have any conductor here. Mind it. Is it clear?
Okay, sir.
So don't mix up. Huh? Here we have
Okay.
alpha source. That's why we are following the conventional current flow for alpha. Beta source, this is electron flow, which is opposite of conventional current flow. Already you noted down, right? 3 points over there. Isn't it? I told
Yes,
you
sir.
to write. Okay, now any more questions?
Yes, sir.
Anything else?
No, sir.
Done?
Yes,
You
sir.
you did the drawing?
Yes, sir. I did the drawing.
You wrote the point that it is out of the page, magnetic field is out of the page.
Yes, sir. I wrote it beside the diagram that it is out of
So
the page. It
any
is
more
towards us.
questions? Any more
No,
questions
sir.
about the alpha, beta, and gamma deflection in magnetic field?
No, sir.
So it's clear.
Yes, sir.
So what we did today?
Sir, we did.
Uh,
Yes, sir. So, did you see something? Sir,
Yes, yes. Tell me,
So did
please.
you say something to me?
Yeah, now tell me, please, quickly.
Sir, your sound is very faint. Could you be a bit louder?
Yes, tell me,
Yeah,
please.
yes, sir. Yes, sir. At first, we did the detectors, means detector of different types of nuclear emissions. Then we did the characteristics of types of emission. Then deflection, and in deflection, we also did behavior of three types of emission in a magnetic field. And now we are in flaming hand rule.
Okay, so till this part today, okay, you, I think, get some more questions to solve from worksheet. Please do it. Karim,
Okay, sir.
don't delay,
And I
huh?
will
You,
also check the structure part now.
yes, you check structure part and also MCQ part, you will get lots of question now to solve. Because you know about the characteristics of alpha, beta, gamma now. You know about
Okay, sir.
behavior in magnetic field, electric field. You know about the detectors, right? Lots of
Sir, we
ideas.
still have the 10 minutes left. Can't we do a bit more?
What?
Sir, we still have 10 minutes left. Can't we do a bit more?
No, no, we cannot do anymore. It's already 9 o'clock. We have to stop here, okay? Hello?
Yes,
We will
sir.
continue from nuclear reactions, the new thing. That's why we will not continue today anymore. You just try to solve the questions related to the things we already done, okay? And
Okay, sir.
also we did nuclear atom, but complete topic. So try to do as much as possible. That will be more beneficial for us. This 10 minutes you use for that. Thank you so much, okay?
Okay, sir. Have a nice
And
day. Assalamu alaikum.
try to be on time, huh? Thank you. Allah Hafiz.
Okay, sir.